Hello, I'm Matteo Fabbri from the University of Modena and Reggio Emilia, and I'll explain how synthetic data can help pedestrian detection and tracking. Deep learning-based methods require large volumes of training data to achieve good performance. However, data acquisition in crowded public environments raises data privacy concerns. Furthermore, the annotation of such data usually requires a substantial amount of manual effort, especially in the video domain. Labeling instances of pedestrian in highly crowded scenarios can be challenging and may introduce errors in the training data. Also, for some types of data like 3D poses, manual annotation is not feasible. Last but not least, the COVID pandemic could hinder the recording of new video sequences of crowded scenes. A possible solution is to employ virtual worlds. In fact, storing virtual world data is GDPR compliant, as no real human ever gets involved in the process. The automatic annotation granted by the simulator completely removes manual effort, making the annotation error-free and always consistent. Also, virtual worlds allow the collection of data that cannot be manually recorded, like 3D poses in the realistic crowded scenarios. As our simulator, in this work we use the Grand Theft Auto 5 video game. By injecting code into the game engine, we were able to create MOTSynth, a large synthetic dataset for pedestrian detection, tracking, and segmentation, designed to replace recorded data. MOTSynth comes in bundle with temporally consistent bounding boxes and instant segmentation labels, 3D poses with occlusion information, and depth maps. MOTSynth contains more than 40 million annotated people instances over almost 1.4 densely annotated frames. Compared to real-world urban surveillance datasets, MOTSynth has one order of magnitude more clips, annotated frames, and annotated instances. In this paper, we aim to answer a challenging question. Can we advance state-of-the-art methods in pedestrian detection and tracking using only synthetic data? To this end, we firstly trained several state-of-the-art models for pedestrian detection, re-ID, tracking, and segmentation on synthetic data and evaluate their performance on the real-world pedestrian tracking datasets MOT17, MOT20, and MOTS. The comparison is done against the same models trained on state-of-the-art real-world datasets, like COCO, CrowdHuman, Market, and Chuck. For people detection, we used 4 heterogeneous detectors: YOLOv3, CenterNet, Faster RCNN, and Mask RCNN. By training the models on MOTSynth, we consistently outperform models trained on COCO. For person re-identification, MOTSynth training has been compared to Market and Chuck. The results show that our synthetic training outperforms the union of both real-world re-ID datasets. This suggests synthetic datasets can be used as a full replacement for re-ID applications. For tracking, we experimented with Tractor and CenterTrack. Experiments, once again, show that MOTSynth training is superior compared to COCO and CrowdHuman training, even when fine-tuning on MOT17, further showing that MOTSynth is more suitable for pre-training compared to real-world datasets. For tracking and segmentation, we report a similar trend. In particular, Mask RCNN Tractor, trained directly on MOTSynth, outperforms Tractor by a large margin. It is important to note that this model is trained only on synthetic data, whereas other methods reported were trained using MOTChallenge or several datasets. Are other synthetic datasets able to bridge the gap? To answer this question, we trained the detectors on other synthetic datasets. MOTSynth-based training clearly outperformed alternative synthetic datasets by a large margin. Finally, we evaluate our models on MOTChallenge test set using the public benchmark. We obtain highly competitive results when solely training using synthetic data. In fact, on MOT17, Tractor trained only on MOTSynth outperforms Tractor trained on COCO and fine-tuned on MOT17. Additionally, CenterTrack trained on MOTSynth and fine-tuned on MOT17 establishes a new state-of-the-art. Here, some qualitative results show some detections obtained with YOLOv3 trained from scratch on MOTSynth. The neural network has never seen real people, yet it's able to detect them. And this is awesome. In conclusion, synthetic training has always performed favorably, indicating that MOTSynth can completely replace manually annotated datasets while increasing performance. Also, we show that prior synthetic datasets are not suitable for bridging the synthetic-to-real gap. Lastly, we obtain state-of-the-art results on the MOTChallenge MOT17 dataset by training recent methods using solely synthetic data. We believe this paper will pave the road for future efforts in replacing costly data collection with synthetic data in other domains. Thank you.